On problem number 15 and 16, they want you to find the radius of the circle, the distance from the center to the edge. The given information is that the length of chord EF is 16 and the length of chord HG is 16. If chord HG was closer to the center of the circle, then it would be a longer chord. If chord HG was further from the center of the circle, then it would be a shorter chord. But since chord HG and EF are exactly the same length, then they are the exact same distance from the center of the circle. That allows you to write this equation. The distance QA, which is the distance from the center to the chord, is 4x plus 3, and that has to be exactly the same as the distance from Q to B. So 4x plus 3 will be equal to 7x minus 6. If I subtract 4x from both sides, I will have 3 equals 3x minus 6. If I add 6 to both sides, I will have 3x equals 9. If I divide both sides by 3, I will know that x equals 3. That's the first part of the problem. Now we can figure out what the actual distance from the center of the circle is to chord EF and from the center of the circle to chord HG. And 21 minus 6 is 15. So the distance QB is 15. And if we figure out the distance QA, it will be the same. So that'll be 12 plus 3, which is also 15. So this is 15, and this is 15. Even though we've done this much work in the problem, we still don't know what the radius is. The radius is going to be the distance from Q to G, or Q to H, or Q to any other point on the circle. So if we want to find that radius, we're going to have a right triangle that looks like this. The distance that we just calculated was 15. Half of the length of the chord is 8. And we want to know what the radius is, which is now the hypotenuse of a right triangle. So if we use the Pythagorean theorem, r squared will equal 8 squared plus 15 squared. So r squared will equal 64 plus 225. So r squared will equal 289. And then when we take the square root of both sides of the equation, we find out that the radius is 17. If you remember from Math 2, we could have skipped the entire last step if we would remember that 8, 15, 17 is a Pythagorean triple. And then we would know that the radius was 17 without having to do the calculations. In problem number 16, the difference is now they're telling us how far away the chord is from the center of the circle. And since chord BC is 5 units away from the center, and chord AB or AD is 5 units from the center, then those two chords have to have the same length. If one of the chords moved further away, it would be shorter. If one of the chords moved closer to the center, it would be longer. But since they're the same distance away from the center, they are going to be equal, which allows us to write the equation 4x plus 4 has to be equal to 6x minus 6. So now if I subtract 4x from both sides, I will have 4 equals 2x minus 6. And if I add 6 to both sides, I will have 2x equals 10. Then I divide both sides by 2, and I find out that x equals 5. This will allow me to now calculate the length of each chord. So this will be 4 times 5 plus 4, which is 24. And this will be 6 times 5, which is 30, minus 6, which is 24. So both chords are the same length because they're the same distance from the circle. The chords are also divided evenly. So the 24 is broken up into 12 and 12. And they want us to find the radius. And the radius is the distance from Q to B, or the distance from Q to any other point on the circle. So that leaves us with a right triangle that looks like this. And this is going to be the radius, and this is going to be 5, and this is going to be 12. So if we want to find the radius, it's the hypotenuse of the right triangle. So that's going to be 25 plus 144. So r squared is 169. And we take the square root of both sides, and we find out that the radius is 13. And again, if you were going to remember from last year that 5, 12, 13 is a Pythagorean triple, you could have known that the radius was 13 without doing the Pythagorean theorem.